Welcome to aminacademy.com. In discrete mathematics regarding probabilities, let us discuss about independent event. Independent events are those events whose occurrence is not dependent on any other event. For example, if we flip a coin in the air and get the outcomes of as head, then again, if we flip the coin, but this time we get the outcome as tail. In both cases, the occurrence of both events is independent of each other. That is, it is one of the types of events in probability. Let us learn here the complete definition and independent events closing with us as a diagram and some examples problem also. What are the independent events further? In probability, the set of outcomes of an experiment is called events. There are different types of events such as independent events, dependent events, mutually exclusive events, and so on. That means if the probability of occurrence of an event A is not affected by the occurrence of another event B, then A and B are said to be independent events. Now, further detail. Look at these figures. These are the chances of getting probabilities. Like if probability 0, it is impossible events. It is 1 in 6 chance. It is called unlikely. Even chance means 1 by 2. That is 3 out of 6 chance. Likely is mostly about 4 and 5 chances. And certain 100% chance is 100% chance is 1. Probability is 1. Independent event formula is P of A intersection B is P of A into P of B, or P of A, we can say it is P of A slash B. Independent event in probability are events where the outcomes does not affect the probability of the other. For example, flipping a coin multiple times, the result of the first flip does not change the probability of getting a head or tail on the next flip. The probability of two independent events both occurring is found by multiplying their individual probabilities, like P of A and B is equal P of A into P of B. Some key characteristics. No mutual influence. The occurrence of one event has no impact on the probability of the other event. Memoryless. Independent events have no memory of past results, both because all are independent. Mathematical formulas, the probability of two independent events A and B both happening is the product of their individual probabilities, that is P of A intersection B is equal to P of A into P of B. Flipping a coin is an example. Rolling dice also an example. Outcome of the rolling a die doesn't affect the outcome of the next roll. Drawing cards with replacement. If you draw a card from a deck of card, note it and then put it back before drawing the second card. The two draws are independent events because before 52 cards, after drawing one card and notice it and get back, put it in card itself, replaced. That is further it is 52 cards, so it is an independent event. That means if you select another card, it is independent probability of first. Non-example, that is dependent events. Drawing a card from a deck without replacement. That means if you take out one card and calculate the probability of that card, then don't replace it. Then second card selection means out of 51 card only you are selecting one card. So it is a not independent event. It is dependent event. The outcome of the first draw does affect the probability of the second draw, so making them dependent event. Now, independent events are events whose probability of occurrence is not affected by the other event. We know that. For example, if you roll a die twice, the outcome of the first row and second row have no effect on each other. They are independent. That means first first row we are getting outcomes 1, 2, 3, 4, 5, 6 possible are the same on each row. The second row here, first row here. This faces says that outcomes of two thrones. Two throws is 1, 1, 2, 1, 3, 1, 4, 1 up to 6, 6. Here, if two events are independent, then P of A and B is equal to P of A into P of B. This is called the multiplication rule. Look at an example. If you are rolling a dice twice, we can find the probability of getting two sixes. That is one. The probability of getting a 6 in first throw, it is 1 over 6, and second throw is another 1 over 6. Totally, the product rule 1 over 6 into 1 over 6 is 1 over 36. That means you're getting chance 6, 6 is a 1 over 36. Now, look at this example. One more example. Of the events E, that E is a family with 3 children, has children of both sexes, and F is that the family has at most one boy. Are independent. These events are independent or not. Assume that the 8 ways as family can have 3 children are equally likely. Now the sample space is 3 children in each 3 children in each families. Look here, these are sample space. Look at here. Families can have 3 boys, 2 boy, 1 girl, 1 boy, 1 girl, 1 boy. Like these are the sample space. Outcome is 8. Now here first net E, the event E. What does event E represent? The family with 3 children has children both sexes. Here first event E can be written as BBG, BGB, that is even is families children have both sexes. Here that is every outcomes there is a both sexes. That means there is no all boys, there is no all girls, so mixed. The next one, next is event and F. What is that F? Event F. Even if says that family has at most one boy. At most one boy maybe, at most one boy is maybe one boy, two girl, one girl, boy, girl, one boy, two girl, and F is, sorry, here, in order we will write here, BGG, one boy, two girl, girl, boy, girl. This event says the families have 3 children, at most one boy. That means what? Maybe what? One boy, two girl, and no boys. This is called at most one boy. Here, this we have 1, 2, 3, 4, 5, 6. This is a 6 here. is a 4. Now, E of intersection F. What is E intersection F? BGG. This is BGG and common between them GBG. This GBG and next one double GB and triple G. 1, 2, 3, 4. 4. Now we will calculate first probability of E intersection F equal 4 over 8. This 4 over 8 kp. Then P of E into P of F. We are calculating this. P of E. P of E is 6 over 8 into P of F is 4 over 8. Is equal 24 8. Which is equal 3 over 8. Here E intersection F is BGG and GBG and GGB. This not there, sorry. Here it's not a common. It is 3 outcomes. So, and also we have E over F, E over 8. From these two results, that is, we can say, therefore, P of E into P of F equal P of E intersection F. Therefore, the two events are independent. The two events are independent. We got it. So far, we discussed about what is independent event and we described two problems on it. We have done. Please subscribe our YouTube channel.